Okay, hello everyone. Welcome to spotoer's live class about the BGP protocol. Actually, it's our third time talk about the BGP protocol, and it's the last time. We will talk about how to control the BGP route. So, first of all, maybe you missed the last two times live class about the BGP. You can find us on the Facebook and YouTube. You just need to search the spotoer CCI Club in the Facebook and also search the spotoer on the YouTube, and don't forget to follow us. And also we have a WeChat group, and this is our WeChat group's link, so you can use this link to join us. And in this group we have different students and different teachers, and we can discuss the questions together, and we will provide you some free information about the Cisco certificate. Okay, so don't forget to follow us and don't miss our free live class. And for today, we mainly talk about how to control the BGP route. Actually, in the last two times live class, we learned what's the BGP protocol. And in the BGP protocol, actually, we have two different BGP neighbor relationships, the eBGP and the iBGP, and we know how to configure it. And in the last time live class, we talk about the BGP advertisement principle. So we need to know that in the different situation, the BGP maybe need to follow the different advertisement principle. So for this time's live class, we will mainly discuss how to use the different attributes to control the BGP route. So for this class, we have three parts. The first one is the different attributes in BGP protocol, and then is how to control the BGP routes. So the last one is how to configure it. I will use an example to show you how to configure it. Okay. So first of all, we have one topology and we have some problems. So we can see here in this topology, we have actually 7 different autonomous systems, 7 different AS. And we can see here for the AS7, we can find a network segment is 100.0.0. And if the AS1 and AS3 wants to learn the network segment information, so the AS7 needs to send the route to AS5 and send it to 6. So 6 need to send it to 3, and 5 send it to 4, 4 send it to 3. So in this situation, we can see here the AS3 can learn 2 different routes, but with the same destination. So if AS3 advertise this route to AS6 and also advertise this route to AS4, so we can see here a loop maybe happen. So in this situation, actually is the same. AS3 will send it to AS2, and 2 send it to 1, 1 send it to 3. So in this topology, we can see here, if we want to advertise the BGP route between the different AS, so maybe the route will have the loop. We know that the loop is very serious problem. So if our network have a loop, the network will be broken down. So this is the first problem. We need to know how to prevent the loop in this topology, and then we need to know how to let the AS3 can select the best path. So actually, for this situation, we can see AS3 can learn the routes from AS4, and also AS3 can learn the routes from AS6. So this is the first network, and this one is the second route. So how can the AS3 select the route? So maybe we can see here, this link is with the bandwidth is 100, but this link is 50, 100. So we want AS3 can learn the route from AS4. So how can we control the route? Actually, in this topology, we have these 2 different questions, and then we need to know how the BGP can control the route and prevent the loop. So first of all, we need to know different with the IGP protocol. The BGP protocol has rich attributes here, and this attribute will be carried in the BGP route, will be carried in the BGP packet. So it's very important. And we can see here, the BGP attributes have 4 different paths. The first one is the will known mandatory. So in this attribute actually is the will known. It means all the BGP routers can recognize this attribute. And for the first type, it means each route needs to include these 3 different attributes. So we know that this is the first type. And the second one is also the will known. It means each router can recognize it, but maybe some routes will not include this attribute. Okay, so these 3 routes, we must include it in our BGP route. But these 2 different attributes, maybe some route can include this attribute, but some of the route will not include it. So actually, this is the first 2 different types, the will known mandatory and the will known discretionary. So the next one is the optional. It means maybe some BGP route can recognize it, but some can't recognize it. So for the first one is the optional transitive. We just said maybe some router can't recognize this attribute, but they can still transmit this route. So this is the first type of the optional attribute. And the next one is if the router can't recognize it and also the router will not transmit it. So it calls the optional non-transitive. So actually we have so a large number of the attributes in the BGP protocol, so we divide it into the will known and the optional, and we have 4 different. It's the will known mandatory, will known discretionary, and optional transitive and non-transitive. We need to know and remember these 4 different attributes. So next one, we need to learn more details about the attributes. So first one we need to know is the VAT. So we can see here, actually the VAT is the Cisco private attribute. And in this topology, we have 3 different routers, and between A and 3, we have these 3 different network segments. And B is in another AS200. So between A and B and C and B, they are the eBGP neighbor. So we can see here, the RTB can learn this route from RTA, and also RTB can learn this route from RTC. So in this situation, actually we can configure the different weight. So just like I will establish the eBGP neighbor with route A, but I set the weight is 100. But maybe I set the weight between B and C is 10. So the higher the value, the higher the priority. So if the RTB can receive 2 different routers with A and C, so RTB will think the route received from RTA is better. So this is the first attribute called VAT, and we need to know that the VAT value ranges from the 0 to 65535, and the higher the value, the higher the priority. So also the default value is the 32768. We need to remember it. Okay, so this is the first attribute. In this situation, we can just use the VAT to control the route. Since RTA with a higher rate, so the RTB will think the route learned from RTA is better. And the next one is the original. So this attribute is used to indicate the origin about this route. So actually in the last live class, we just talked about we can use the network and the import to let the BGP import route and transmit the route. So in this situation, we can see here, if you use the network command, so the route will have the attribute of the original, means this route is network, and another one is the import. So in this situation, we can see here in this topology, we have two different AS, and this one is AS 100 and this one is AS 200. So between A and B and A and C, they are the eBGP neighbor. So this one is the network segment 200.0 with mask length 24. So RTA wants to learn this network segment information, and we can see here RTA can learn the routes both from RTB and RTC, but the origin of this route is different, because for the first one we use the network command, but for the next one we use the import command. So we will think the network is better than the import. So in this situation, RTA will think the route learned from RTB is better. So it depends on the origin of this route. Actually, we have three different origins. The first one is the network. We use I to identify this route. If you use the network command, so the symbol will be I. And then the next one is the eBGP neighbor. Actually, at first, eBGP is also a protocol, but the design is very bad, so we discuss this protocol and we use the BGP protocol today. But we still have a symbol called E to identify this route. The origin of this route is eBGP, and the next one is the import. So we use the import to let this route can be transmitted in our BGP protocol, and the symbol is the question symbol. So we need to know that the network route is better than the eBGP route, and the eBGP route is better than the import route. So in this situation, we can see here RTA will think the first one is better. Okay, so this is the origin route about the route. And the next one is the AS path. So the AS path is very, very important because it can solve the problems we just talked at first. So we can see in this topology, actually we have 5 different AS. And in the AS4, we have one network segment is 100.0.0.0 with mask length is 24. So in this situation, we just said that the RTE will send it to RTB, and B send it to C, C send it to D. So D will send it to E. In this situation, we can find a loop will happen in our network. So we will use the AS path to prevent the loop. It means when RTE try to send the route, it will carry the AS information in this route. So when RTE send it to RTB, so in this route, it will have the information with the AS4. So when RTB receive this route, it will know I learned this route from AS4. And then when RTB send this route to RTC, so in this AS path, we will have the 4AS and the 2S because RTB belongs to RT2, belongs to AS2. So when RTC receives this route, RTC will know this route is transmitted from AS4, from AS2, and then I receive it. So when RTC send it to RTD, this network will carry the AS path is 4, 2, and RT6 AS is 3. So RTD receive it, RTD will add its own AS number, so this route will carry the AS path information is 4, 2, 3, 5. So finally, this route will send to the RTE, and then when RTE receive it, it will check the AS path list. So RTE will find the list have the AS4. So it means I just send this route. So finally, I will not receive this route because I just send it. So it means if the AS path list has the same value with RTE's AS, so the RTE will not receive it. So in this situation, we can see RTE will discuss this route, so the loop is broken. Actually, this is the first function about the AS path. It will record the path list about this route, and then if the router can find its own AS value in the AS path list, so the router will discuss it. Okay, so this is the first one, and the next part is we can see for this network segment, RTE send it to B, so B send it to A, and also E send it to D, D send to C, and C send to A. In this situation, we can see here RTA can receive these two routes from the RTB and the RTC, but actually the destination is this one. Actually, the destination is the same. So how can the RTA select the better path? So we just talk about the original, and the original is the same as the network. And we talk about the VAT. Actually, VAT is also the default value, and they are also the same. So we will use the AS path list. So when RTE sends the route to RTB, it will carry the AS path list is 4, and RTB send it to RTA. The AS path list is 4 and 2. So for the second route is E send it to D, so the AS list is 4, and D send it to C, so the AS list will add 5, and C send it to A, so the AS list will have 4, 5, 3. We can see RTA can receive these two routes. The first one with the AS list is 4 and 2, and the second one with the AS list is 4, 5, 3. So RTA will think the first one, the first route has passed 2 different AS, and the second one has passed 3 different AS. So it can just think the first route is more closer in the transmit path. So it means the first route has just transmit through 2 AS, but the second one is through 3 different AS. So RTA will think the first route is better because AS path list is shorter than the next one. It's just 2 paths, but this one is 3. So when the router receives 2 routes from the different AS, it will compare the AS list in the AS path. So the router will select the route with the shorter AS path list. So in this situation, first of all, the AS path will prevent the loop, and the second one, the RTA, will use the list length to select the better path. Okay, so this is about the AS path. And then next one is the next hop. So actually it's very, very important, because if you try to send the route to your neighbors, you need to tell him what's the next hop. So in this situation, we need to know that when RTA try to network this network segment into the BGP protocol, so RTA will send it to RTB. Yes. So when RTB receives its route, actually the next hop is RTA. So if RTA use the loopback interface to establish the neighbor relationship with RTB, so the next hop of this route will be RTS loopback interface. And then RTB will send this route to its own eBGP neighbor RTC. So in this situation, when RTC receives the route, the next hop will be RTB. Okay, so it means when RTB sends the route to the eBGP neighbor, it will change the next hop to itself. So when RTC receives it, the next hop is RTB's this interface. And then if we have a physical interface just between RTC and RTD, in this situation, when RTD sends the route to when RTC sends the route to its iBGP neighbor RTD. So in this situation, if the router receives the eBGP neighbor and then sends this route to the iBGP neighbor, it will not change the next hop. So in this situation, RTD will think the next hop is still RTB's this interface. Okay, this is the default situation. We need to know that when the router receives the route from the eBGP neighbor and send it to the iBGP neighbor, it will not change the next hop. So RTD will think the next hop is RTB. But we can see here, actually, if RTD thinks the next hop is this interface of RTB, so the next hop is invalid. So it means this route is not best and is invalid. I can't use this route. So when we try to configure the BGP neighbor in the between B and D, we need to use the command neighbor 4.4.4.4, and also we need to set the next hop is RTC local. So the next hop is self. Okay. So when we try to configure the iBGP neighbor, we need to use this command to change the next hop to RTC's this interface. So this is very important. Okay, it's very important. And then actually in this situation, we need to know that we need to configure the command and let RTC can think the next hop is let RTD can think the next hop is RTC. Okay, so for this one is the next hop attribute. Now the next part is about the local preference. Actually, the local preference is used to control the traffic leaves the AS. So we can see here in this situation, we have two different AS. So this network segment is from this network segment is 1200, and then RTA can receive these two different routes from B and C. So the route will be transmitted just like this. So RTA will think which way is better. So we can see here for the first route, the bandwidth is 50, but for the second one, the bandwidth is 100. So we can see here we need to select a path with the larger bandwidth. So we want the RTA can select the second route. So in this situation, we can use the local preference. So when RTB try to send the route to RTA, it will carry the local preference. So the local preference value, the default value is 100. And for this one, if you want the RTA can select the route from RTC, the default value is 100, and the higher the value, the higher the priority. So we need to change RTC's local preference become a larger value. So you can just change it to 101. So in this situation, RTA will compare the local preference of these two routes. For second one is 101, but for the first one is 100. So the RTA will think the second route is better. So we can see the route will leave the S100 to S200. So we need to know the local preference is used to control the traffic leaves the S. Okay. So we need to know the default value of the local preference is 100, and the higher the value, the higher the priority. Okay, and for this value, it can just be transmitted in one AS. So it means if you just want to let RTB send one route to RTD carry the local preference, we can't use it. It means local preference can just be transmitted between iBGP neighbors. We also need to remember this. And for the next one, we just said this this attribute is used to control the traffic leaves the AS. And then the next one, the MED value is used to control the traffic go into the AS, enters the AS. So we can see in this topology, we have three different AS here, and in the AS300 of RTF, we have one network segment is 100, and the RTF will send this route to RTB and also send this route to RTB. So also RTB will send it to RTA. So in this situation, if RTA tries to visit RTF, we can see the RTL will send the traffic to RTB, and when RTB receives it, actually it can select two paths. So for the first pass, the bandwidth is 100, but for the second one, the bandwidth is 50. So we want the router can select the first pass. And then in this situation, we can see the traffic will enter the AS. So we can't use the local preference. The local preference is used to control the traffic leave the AS. In this situation, we can use the different MED value. Now, for this attribute, the default value is 0. The default value is 0, and the higher the value, the lower the priority. So if you have two rows, the first one is the default value 0, but the second one is the 100. So this one is better. And then in this situation, the default value is 100, so it means when RTB receives this route from RTD, the MED value is 0. But if you want the RTB think the next one is not the optimal route, so you can just change the MED value between these two different AS. You can just think the AS is the MED is 100. So when RTB receives these two routes, it will compare the MED value. The first one, the MED value is 0, and for the second one is 100. So in this situation, the RTB will think the first one is better. And then when RTA try to visit this network segment, so RTA will send the route to RTB, and B send it to D send it to F. So the traffic will enter the AS. So for the MED value, we also need to remember the default value is 0, and the higher the value, the lower the priority. It's different between the local preference. Local preference default value is 100. The higher the value, the higher the priority. Okay, so and then we have learned some attributes about the BGP protocol. So next one, we have one topology just like this. We need to control the network path with the BGP attribute. For this topology, first of all, we need to know that for the AS100, we have 3 different routers, and they are the iBGP neighbor. So the RTA has a network segment 1.1.1.1, and also for RTD, it's in the AS200. Now, the RTD will establish the eBGP neighbor with the BCEF in the physical interface, and for the AS300, we have 3 different routers. But for the RTG, we can see here, RTG we have one network segment is 7.7.7, but for the next loopback interface is 17.17.77. So in the default situation, the RTG will send the route through EDBA, and also for the next one. So RTA will receive 2 different routes from the 2 different routers, but when RTA tries to visit the network 2 and the network 3, it will both select the first path, because in the default situation, the RTA will select one path as the best path, but RTA will both select the first one according to the different attribute. But we want to change the path. If RTA try to visit network 2, it can use the first path, but RTA tries to visit the network 3, it can use the second path. So I will use our spotoers out laboratory to show you how to control it. Okay, so in this situation, actually the topology is the same. We have 7 different routers, and they are in the 3 different AS. Okay, so next one, we can check the configuration here. So for the R1, if we want to use the different attribute to achieve this M, actually we have different ways. For our spotoers live class, I will just show you one way how to achieve it. So first of all, we can use the command to show IP BGP to check it. So we can see here R1 can receive the root of this network segment from 2 and 3, but R1 think the first one received from 2 is better, and also R1 will receive this network segment from 2 and 3, and R1 will think the first one received from R2 is better. So in this situation, all the traffic will be forwarded from the first pass through R1, R2, R4, R5, and R7. So we want to change when R1 visits the second network segment is the 17.77.77.77. So in this situation, we want to think R1 will think the next pass is the best. Okay, so we can see here, we just talk about this topology. If R1 receives this two routes from R2 and R3, we can use the local preference to let R1 think the route learned from R3 is better. So we can change the local preference in the R3. So first of all, we need to use the different route map to match the different route. So first one, we need to use the access list, name is 1, to permit this route 77.77. So we need to permit this route, and also we need to use the route map. Use the route map to match this access list. So we just have the name is local preference. This is the name of this route map, and the first one is permit 10. So we need to match the IP list. Access list is 1. Access list is 1. And also for this route, we need to set the different local preference. We just said the local preference of the route, the default value is 100. So if we want R1 can think the route learned from R3 is better, so we need to change the value is larger than 100. So we can just think the local preference value is 200, and the next one is for the route map. Another route map is the local preference permit the other route. Okay, after we just change the route map, so we need to apply it for our neighbor. So we need to enter the BGP view, BGP 100, and the AS number is 100. And when we try to neighbor the R1, so the neighbor 1.1.1.1, and we need to use the route map. So the route map is the local preference, and the direction is out. So it means R3 need to send the route to R1, so the direction is out. So okay, that's the configuration of the R3. It means in this situation, R3 will receive the route from R2 and R3, but the route learned from R3 has the higher local preference, so R1 will think the next route is better. So we can see here, for R1, we can use the command to clear IPBGP, and then we check the BGP neighbor. So we can see here, we can check the configuration. So we can check it to show run about the configuration. So first of all, we just configure the access list to permit the route. And the next one, we need to use the route map to permit it. The route map is permit 10 and just set the to match the IP address and set the local preference is 200. And then when we try to configure the neighbor, it's neighbor this one, the local preference is out. Then we can remove this command. Okay, then we try to refresh it. Clear. We try to clear it again. So wait a second. Let the R1 can establish the relationship with R3. Clear IP BGP. We can check it again. So run. Check all the configuration. Also for R3, it's up. So we try to check it again. Okay, sorry. For this command is so we can continue to do the next part about the R4 and the R6. So we can to check the R4's IP routing table. So we can see here is show IP show IP BGP. We can see here for R4 we can also receive the two routes from R5 and R6. So R4 will think the route learned from R5 is better. So we can just change the different MED value in the R6. So it means the default value R4 received from R5 and R6 is 0. And in this situation, we can change the MED value received from R6. The default value is 0, and if we just change the MED value, so it means for the first one, if we configure the MED value in the R5 to change it to 100, so it means R4 will select the first one as the best route. Okay, so in this situation, after the configuration in the PowerPoint, we can check the configuration here. So in this command, this one is the default value. So actually we just see it, and this is the path. So the default value, the R1 will think the route learned from the R2 is better. So we can see here the R2 is better. But after we change the local preference, so we can see here we change the local preference received from R3 is 200. So R1 will think the route learned from R3 is better. And in the IP routing table, also the R3 is the next hop. And for the MED value, so we can see here we just change the MED value received from R5. So we can see the value has changed. So the default value is 0, so we can't see it. We can see here the default value is 0, but if you change the MED value received from the R5, so we can see here the R4 will think the route learned from R6 is better. So the next hop will become R6. So in this situation, after we change it, the path from R1 to the first network segment, it will use the first path, and for the second one is the second path. So actually, that's the phenomenon of this lab. So we can go back to check it again. So for the R1, it just can't establish the neighbor. So we try to clear it again. Clear BGP, sorry, AP BGP. Okay, so it has established the neighbor, so we use the command show IP BGP 23.3. So it means for the route map, I just remove the command, so the R3 can't send the route. So we need to add this command is the route map to permit the other route is the route map, the local preference, and the permit 20. Okay, so next one we go back to R1 here. Try to check it. Clear it again. To clear it again and check it. So we go back to R3 to change the to check the configuration. Show the configuration, show run as BGP here. So to network 1.1.1.1, the local preference is local preference out. And also to show, to check this, to permit access list to permit this network segment, and the match IP address is 1. The next one is set local preference, LCLPRE. Local preference. Actually, we can see here, we just configure the run name. So that's the run. So we use the run name here. So first of all, we need to delete this command and then add a new command is about the, this one is the route map and permit 20. And for our BGP configuration, the route map name is the different. So that's the run. So the router BGP 100. And then we can check it. The configuration is just like this. It's wrong. So we need to remove it. And then we also need to use the command is neighbor 1.1.1.1 and the route map is local, sorry, preference is this one, and the direction is use it local preference and the direction is out. Okay, so that's a configuration. I just spell the wrong route map name, so the R1 can't learn the normal route. So for this one, we check it again. So we can see here in this situation, I use the right name of the route map. So we can see here, the R1 will think the route learned from R3 is better. It's with the local preference is 200. So we achieve the first M. And the next one, we need to check the MED value of the R5. So actually the configuration step is the same. First one, we need to configure the access, the access list to match the route. So sorry, access list is 1 and we need to permit the route. It's this one. This is our destination, and we also need to config T. We also need to use the route map. The name is MED, so we need to make sure the name is right. So the name is MED and permit the and we need to match the access list. Match IP address is 1. Set the MED value. So we just set the MED value. The default value is 0. So we need to set the value is larger than 0. So we can just set the value is 100. And also we need to configure another map is route map med to permit another list. Okay, then next one is we need to use the route map between the different neighbor with R4 and R5. So we enter the router BGP 300 and then neighbor the neighbor address is 10.1.45.4 is the IP address of R4 this interface. And then we need to use the route map. The route map name is MED and the direction is out. Okay. So that's the configuration about the R5. We just check the route MED value of the R5 and then we go back to R4 to check it. We can see here the original route info, the route IP BGP routing. We can see the R4 will think the route learned from R5 is better. So after we do that, so we can we need to clear it. Clear IP BGP. Okay, so after they establish the neighbor, so we can find this. The MED value of the route learned from R5 has become 100. So the R4 will think this route learned from R6 is better. So we can see here, we just change it. For this one, R4 will think this one is better. Learned from R5 is better, but after we change the metric, the R4 will think the route learned from R6 is better. So in this situation, I just show you one way how to configure it. So we go back to the PowerPoint. Actually, in this topology, we have different ways to use the attribute to achieve this aim. So for this lab, we just change the local preference of RTC. When RTC sends this route to RTA, we set the local preference to 200. The default value RTB will send it is 100. So RTA will think this one is better. So between RTD and E and F, so we just change the metric value of RTE's route. We change it to 100, and the MED value is 0. So the RTD will think this one is better. So in this example, we just use the local preference and the MED value to achieve the aim. So when RTA receives the RTG, it will just choose the second path. But we also have different ways. So for example, you can change the length of the S path, and also you can directly change the next hop of the route. So for this one, you can find how to use the S path and how to use the maybe use the origin, maybe use the next hop to achieve this aim. Okay, so you can find the way. So in our live class, we can just show you this one example. Okay, so that's the example about our this time's class. So at last, I will show you the principle when the BGP tries to select a path. So first one, the BGP will select the route with the highest value is the Cisco private attribute, and then next one, choose a larger local preference, and then choose the local as router. So next one, a route with the shorter as, and select the origin is IBGP is better than EGP. So IGP is better than EGP and is better than the import. So next one is the MED value, and it will think the eBGP is better than the IBGP. Actually, it's also used to prevent the loop. But for our live class, we can't talk this all details, so we just need to remember this. And the next one, choose the next hop with the lower IGP metric. So if all these paths all these attributes are the same, so we can achieve the load balance. So in the default situation, the BGP router can't support the load balance. So if you configure it, it will achieve the load balance. But in the default situation, it will continue to compare it. The oldest route, it means the order will be the stable. The next one is used to select the route, advertise the BGP peer with a smaller BGP route ID. So we can see here for the default situation in this part, we need to know that why all the route will be received from RTB, because the RTB has the smaller route ID. So RTL will think all the route will be transmitted through RTB. Okay. So this step, the R2 has the smaller route ID, and next one choose the cluster list. So this one is used in the reflector. So it's used to recognize the cluster ID of the reflector. And the next one, we configure the neighbor IP address will learn the route with the smallest IP address. Okay, so that's all about the BGP selecting path principle. And actually this path, this principle, these steps are very important. So maybe you try to learn the BGP protocol, I think you need to remember it, how to select the path. And also for this class, the attributes are very, very important. The local preference, the MBD value, and the next hop. So it's all very important. So I think maybe all of you can find more details and continue to learn about the BGP protocol. So for this one, the lab, we also have different ways to achieve this aim. And also if you buy our spotoer service, our spotoer will provide you the lab, the cloud laboratory. So you can use our spotoer's cloud laboratory to do the exam. Actually, it's very convenient. Okay, so that's all the information about our this time's live class. So at last, so remember the time and don't forget to follow us, spotoer CCI Club and spotoer. If you missed the live class, you can just find the record video in our homepage. So you can still use the WhatsApp group, this link, to join the group, and you can find our teachers, and we will provide you more information about the Cisco certificate, and also we will provide you the service to help you pass the CCI certificate and get your own CCIE. Okay, so I hope I can see you again in our next time's live class, and thank you. Bye.